about how you can do cross-device push notification services using C#, Xamarin, and Windows Azure mobile services. So a bit of a new space for a lot of us, I think. Maybe we've worked cross-device before using the native language of those platforms. Today we're going to look at how we can use C# to do that and use Azure mobile services effectively as our push notification transport mechanism. I'm going to take a little bit of a different approach, I guess, to some of the sessions you might see at TechEd. I'm going to talk a little bit about why we actually need to care about native cross-platform device development. And then I'm going to talk a bit about how Xamarin and C# enable that, so how we can actually do native development across the three main mobile platforms in the market today using one language that we know and love. Once we've gotten through those two items, I'll go through a demo on each of the three major platforms using Visual Studio and some extension tooling from Xamarin to show us how we can build and deploy essentially the same application across those three platforms. And I'll take some questions at the end. It's a fairly big room with not many people, so please feel free to come and grab me afterwards if I don't get to any questions that you might have. So let's start by talking about native cross-platform and why we actually need to care about doing native cross-platform development. So I've got a question for you, and a big audience, so I know it'll take a little while for you to take your device out, but what sort of phone do you have? Now, obviously being here, you're going to have a Windows phone, all of you, I know. No. So if you've got a Windows phone, hold it up. Let me see who's got a Windows phone. So everyone rings, no, not bad, I've got one of those. Nice bright yellow one, a lemon. Okay, that's good. Okay, who's got an iOS-based device? So, that's all right, that's fine, that's all good, it's all good. And finally, who's got an Android-based device? Wow, all right, okay. Good mix of people though, that's good. So we've got people here that are used to using the different platforms. You probably have an attachment to those devices. To a degree, you've either chosen them or they've been chosen for you, and they probably play a pretty important part in what you do day to day. They're probably your calendar, your email, your IM in some instances, and just you organise your life with them, and you probably feel fairly passionate about it, and you'll have a discussion with somebody who doesn't have something that you have about why they should potentially consider switching to the platform you're using. Oh, it's not loud.
Used by moving your enormous phone. You mean the enormously awesome Galaxy?
Search, one trick pony.
Aren't you a little young to have an iPhone?
Let it go.
I sheep, coffee box.
Autocorrect this.
Extreme example of how passionate people can be about devices, but they probably did hit the nail on the head. I'm sure we all know somebody that swears blind that the phone that they've got and the platform they use is far better than anything that you might suggest to them. So individually, we feel very attached to the devices that we've chosen. Obviously at TechEd though, we're also interested about why business is going to care about this as well. As individuals we care, but why should business care? And it's a pretty common four-letter acronym that we've all seen and know and heard a lot about. Bring your own device. And it's a trend that started several years ago, is ongoing, and is not going away anytime soon. And with the changes that we're seeing in things like Windows 8.1 to allow tablet management via MDM applications to be a reality for non-domain joined devices, it's something that we do actually need to start to think about how we deliver line of business applications onto the devices that people are going to be bringing to work. Gartner has done a study that shows that by 2017, at least half of the large enterprises globally is going to be proactively pushing for employees to bring their own devices, which is a fairly big shift in where things have come from if we consider from even just a couple of years ago. Additionally, Gartner also tells us that by 2015, so only in 2 years' time, about 60% of information workers, so that's people like you and I and people who are generally office-bound and sit at a desk and work on standard sort of business applications, 60% of those people will be using a mobile device to access those line of business applications. So that overlap between the bring your own device and the use of mobile devices to actually access those applications is a key trend that we can't ignore, and if we ignore it, it'll be at our own peril. An interesting follow-up statistic to that is that of those 60% of the initiatives to enable people to use those line of business applications using a mobile device of their choice, half of them will actually fail by 2016. So within 12 months of businesses pushing people down that route, half of those things won't have actually worked out. And the main reason that they won't have worked out is because they don't adequately support the devices that the employees are choosing to bring to the workplace as part of the BYOD policy. Just out of interest, and I'm sure it's probably a fairly high percentage, how many people here bring their own device, either officially or unofficially, to work? Okay, so you probably all understand and appreciate what that's about at the end of the day. And you're probably sitting there going, well, okay, didn't HTML5 already solve some of these challenges for us? And you'd probably be right had you listened to a lot of what's been going on in the market in the last few years. But actually, HTML5 complicates some fairly simple use cases on a mobile device platform because of the hoops you have to jump through in order to deliver what is essentially native device functionality through what is a off-device delivery framework. So things that I would put in that bucket would be things such as reliable GPS. So you can certainly do geolocation using HTML5, but exactly how it's going to leverage the inbuilt capabilities of your device isn't always clear if you look at the spec as it's defined by the W3C. Doing things like sign-on glass, where you actually need to require someone to sign on an application, and there are certainly JavaScript libraries that will allow you to do sign-on glass type functionality, but then you have to actually capture that JavaScript input and pipe it off onto whatever it is you're going to store that information in. And then things such as data encryption as well. So again, there are certainly JavaScript libraries that will allow you to do device encryption or data encryption, but they're using JavaScript libraries and they're not going to allow you to use the native inbuilt capabilities on the devices. So if you've got a pin lock on your phone, whether you're on a Windows phone, an Android handset or an iOS handset, when you do that, you're enabling effectively device-level encryption on those devices. So if you write data down onto those devices, once those pins are enabled, you've got a fairly safe guarantee, assuming that the providers of those devices aren't introducing bugs into that mechanism, that the data will be stored securely. There's also patchy and varied support for some HTML5 features across the native web browsers on each of the platforms, and because the web browser typically drives the web view control that's deployed down onto the device, we inherit that patchy and problematic implementation. So I have a question for you. Who can tell me what the top 2 mobile web browsers are, based off of a couple of statistics? Who said Firefox? No? All right, so first one's probably not much of a surprise to you based on market share, and this is probably a bit of a spread between your phone device and your tablet device, because Safari is the native browser that ships with all the iOS-based devices. But the second one might be a bit of an interesting one. So I heard someone say Chrome. Anyone think that might be the second one as well? So someone said the magic word at the back up there. This funny thing called Android WebKit. And that's the default web internet type thing that ships with most of the Android handsets that you get in the marketplace today. So increasingly, some of the higher end, newer handsets are coming with Chrome pre-installed, but for the greater majority of the web browsing users out there that are on an Android handset, they're using this thing called Android WebKit, which is not the same as Chrome. They do share the WebKit rendering engine, obviously, but it's not the Chrome browser. Both Safari and Android have had known issues over the last couple of years. So when Apple shipped iOS 5, they actually broke local storage being persistent between browser sessions and web view use on the device. So if you were leveraging local storage in your application, you effectively had no way to persist data between sessions in that browser. They then changed it again with the update to iOS 6, so that it's actually now a flag where you can determine in your code whether you want to persist that information or you don't want to persist that information. But through one generation of the release of the application, the operating system, the web view control went through some really weird changes, and if you were relying on it, you had problems. Android WebKit hasn't really had much love since 2011. I guess Google's been concentrating most of their effort on building out the Chrome capability and pushing that as the browser of choice. So there are a lot of things that have been introduced into the market in the last couple of years that if you're leveraging Android WebKit as your primary web view control down on your device, you're going to have challenges with that. And there's a few people in the marketplace that are sort of saying, well, Google needs to figure out what it's going to do and maybe roll some of those changes from Chrome back into WebKit so it's more standards compliant and it behaves itself in the way that we expect it to. And an example here, so this is a online website you can go to, a fairly simple one, and what it does is it tests the web storage capabilities of the browser that's installed on your device. You can do this on a desktop as well if you want, because they're all HTML5 compliant, so they should all offer this as a feature. This is Windows Phone 8 with IE Mobile 10. As we can see, local storage and session storage are about 4.5 megs, thereabouts, a little bit more, with no global storage support. So out of the 3 storage standards, this is what we get if we're relying on the IE10 mobile web view if we're developing a Windows Phone application that leverages it. On iOS 6, exactly the same web page. This is using mobile Safari. It drops right down to just a little bit over 2.5 megs. And that's half effectively of what we have if we're leveraging the native capabilities of Windows Phone's web view control. And then the most surprising one is Android 4.1.2. So it's in alignment with the Safari implementation in that it gives us 2.5 megs of local storage. But if you look at session storage there, it's effectively off the right or the left-hand side, depending on where you're looking at this from, of the screen, because there's just no upper bound. And I'm sure there is an upper bound, which is either when the browser crashes on your device or your device crashes. So your choice on that one. So hopefully I'm making sense and I'm not standing up here and sounding like I'm drinking too much Kool-Aid. But other people in the market have also seen this as well. Obviously the biggest one to date is Facebook. So Mark Zuckerberg stood up at SF Disrupt about this time last year and caused a furor when he kind of said, well, as a company, we probably concentrate a little bit too much on HTML5 at the expense of native. It was just after this that we saw a big flurry of native application focus from Facebook delivering Facebook One and other sorts of applications natively down onto devices. They're still very much a HTML-driven business, and the W3C mailing list after this statement was obviously fairly heavily covered in the press. W3C mailing list, some fairly senior people at Facebook said, well, we don't actually hate HTML5 and we don't think it's a bad thing, we just think that there's probably some maturity that needs to come into the platform before we can look at leveraging it properly. And it obviously has promised a lot to a lot of people in the last few years. And then the other larger well-known group in the marketplace was LinkedIn. So LinkedIn actually came out and said, well, we're going to re-engineer our application to be native first. They still obviously rely very heavily on a web API type backend to drive the native applications they're deploying down onto device. But they said that the HTML5 approach was limiting their ability to give a good user experience. I think the money's still out on LinkedIn's choice to go native. I don't know if you've got the LinkedIn app on your Windows phone. Maybe it's because it's on a Windows phone, but it's not a great user experience yet. But the good thing is that it can leverage the native capabilities of the device fairly easily if and when they decide to invest some time in turning that around. So the bottom line is that HTML5 actually isn't the solution for us if we want to do cross-device application delivery. So where do we go from there? If we can't use HTML5, well, we get to go native. Now, if we'd said we're going to go native traditionally, immediately that's a three times multiplier for the amount of effort you've effectively got to do, and it probably makes the opportunities for you to have a blended team working on all the major mobile platforms you're going to deliver to very hard to make a reality, because you've got Objective-C, you've got Java, and then you've got C#. Obviously all C-based languages, but a very different set of skills required to work with each of those and a different sort of background. So this is where cross-platform using C# and Xamarin comes in. So let's talk a little bit about that. How many people here know that C# is an open standard? So Microsoft created C# and they created .NET, but when they created the language and the concept of .NET, they actually went to ECMA and the ISO and had C# standardized. So there is actually a C# standard available that you can go and either pay for access for via the ISO, or you can download a free copy from ECMA, and it will detail how you can write your own standards compliant version of C#. And the ECMA document's actually fairly accessible. It reads a lot like an MSDN set of user APIs to understand how you would do things such as generics and what have you using C#. Excuse me. Along with C#, Microsoft also put forward for standardization the common language infrastructure, which is all the bits that kind of lie underneath C# and .NET and allow you to do things like compilation and runtime environments like the CLR, which means ultimately that we could go out and write our own if we wanted to and we had enough time. Who's got some spare time on their hands, wants to re-implement .NET on a different platform? Anybody? Anybody? No? So I'm going to talk a little bit about this thing called Mono and the history of Mono. Who's heard of Mono before? All right, okay, cool. Well, I'll be quick then because you're probably all aware of the history of it. So when Microsoft went to the standards organisation and the standards were agreed upon, there's a couple of guys, Miguel de Caza and Nat Friedman, who'd both been interns at Microsoft but decided not to join the business. They'd formed their own company called Xamarin that was doing a lot of open source Linux type stuff in a GNOME space. And when Microsoft and the standard for C# and the CLI were announced, these guys saw an opportunity there. So they started the Mono project in 2001 with the goal to basically take the C# and CLI standards and implement those in an open source capacity to allow you to do things like run .NET on a non-Microsoft platform. 2003, obviously seeing some value in what those guys were doing and looking to strengthen its open source credentials. And Novell's been very heavily involved in things like Zen for quite some time at this period. Novell acquired Xamarin, and with it, obviously, the guys writing on the Mono team at that point. In 2004 and 2008, they shipped version 1 and version 2 of Mono. So they actually got to a point where they felt that they'd implemented enough of the C# standard and the CLI standard to allow them to actually be pretty much competitive with a Microsoft-only .NET view of the world and allow you to leverage that off of the Microsoft stack. So it was about this time that you started to see the ability to execute ASP.NET on Apache on a Linux box. The interesting one from today's perspective is what happened in 2009 is when they shipped Mono Touch. So Mono Touch was the first attempt to focus down on mobile platforms. So this was about a year and a half, 2 years after the initial iPhone shipped, and these guys saw a gap in the market and went after it hard. So Mono Touch was the iOS targeting of Mono to allow you to write iOS applications. So that's been around for a while. It's been since 2009. In 2011, Attachmate bought Novell and the way of the world and IT, people buy people. When they bought them, almost immediately afterwards, they didn't really see a lot of future and a lot of value in Mono. So they effectively laid off the entire team, and obviously everyone was going, well, what does that mean for Mono? Now, Novell does hold some patents around some of the stuff that's been done in Mono, but what happened is the guys from the Mono team went off and they formed this new business called Xamarin in 2011, and then signed a licensing agreement with Novell to basically license Mono from them so that they could take it forward as they have done. So in 2011, they shipped Mono Droid, which is the equivalent of Mono Touch, but for the Android platform, so you can write C# code and deploy it down onto Android devices. And then just last year they shipped version 3, which effectively brings it up to a fairly good level of compatibility with modern .NET development. So talking of that, what's the compatibility like for .NET and Mono? Actually pretty good. So we are, yes, on .NET 4.5 now, but we've got pretty much all of the .NET 4 framework, excluding some of the proprietary pieces that obviously Microsoft has built, like WPF, WCF, and WWF. There was, for a period of time, an inability to do a lot of the ASP.NET type stuff, but a lot of the ASP.NET stuff has come out into the open source marketplace as well. So Microsoft's made some fairly big strides into opening up that platform for people to do development and port these things across onto things like Mono. So MVC3 is obviously completely open source. You can do Razor. You can do ASP.NET 4. The only thing you can't currently do is all the async 4.5 stuff for .NET, or sorry, for ASP.NET, because that requires some asynchronous pipeline components under the covers to drive that inside of ASP. In July this year, there was an extension released which actually adds all the new C# 5 asynchronous capabilities to Mono, which is pretty fantastic. You know, I don't know if you've used the new async model of programming in .NET, but it does away with having to care about thread pools and all that fun sort of stuff that invariably would trip you up if you weren't using them frequently. The easiest way to find out if your Microsoft targeted .NET code is going to be compatible and easily shipped to Mono is to leverage a scanner that the guys at Xamarin have actually built. So obviously with appropriate approval from whoever in your business needs to do that, you can drop assemblies and executables you've written in .NET up into this website, and they'll run a scan across it and tell you how likely it is that you'll be able to take it and just literally run it using the Mono environment without actually having to do anything other than to pull it into a Xamarin IDE and cross-compile using their compiler and use their runtime. Yes? It's a website. So it's, yeah, I don't have the URL on there, but I think it's at scan.xamarin.com. It'll be linked from their homepage. It's fairly new. It's only been out, I think, for about a month or so, but it's definitely up on their website. You can't really see it on that screenshot, but you can see there's a number 1 at the bottom which says choose compiled XE or DLL assemblies to scan, and then there's a drop, like a drag and drop box to drop those things up into. Personally, I'd prefer to see that as a service I can run locally because I'm not sure I want to put my IP up into the cloud. But you know, at the end of the day, if you maybe want to check some assemblies, that's maybe not a bad thing. So let's talk a little bit about native mobile platform support. So we obviously talked about Mono Touch and Mono Droid. So since Xamarin took over the stewardship of those components, they've now renamed them to Xamarin iOS and Xamarin.Android. But they're essentially still the touch equivalents that have now just been obviously added to by the Xamarin team. Because iOS is a static environment, so Apple won't allow you to deploy dynamically compiled or dynamically running code onto iOS. And by default, you can do things like reflection and all that fun stuff in .NET, and it's dynamic to an extent. What the guys from Xamarin have had to do is they use a thing called ahead of time compilation, which actually takes your executable and your assemblies and then leverages a Mac build environment, which we'll see during the demo, to compile those down into a native ARM app. So you actually end up with a static app to be deployed down onto your device. That does introduce some limitations around the sorts of things you can do. So reflection.emit is out. And some of the aspects of generics are also problematic. So you'll probably find it will compile and deploy, but you'll probably get an app crash. Essentially, if the compiler can't determine at compile time what generic type is probably going to pass through that gateway, it can't compile all the necessary code paths, which obviously can result in a runtime crash of your application. For Android, which is different, so Android is a Linux-based operating environment which uses a specially customized and built Java VM that had Google and Oracle in court for God knows how long, arguing about whether or not it was legal. Has its own Java VM and a set of class libraries that sit over the top of that provide most of the APIs. So what they do on Android devices, they actually do compile down into IL like we would traditionally on .NET. They package that up with their own VM, Mono VM, and then they deploy the VM and the IL out onto the device. So effectively you have the Dalvik Java VM and class libraries sitting side by side with your Mono VM and IL. and then the mono VM determines whether it can call Linux directly to do certain sorts of services, or whether it has to leverage the Java API through calls to that to do certain things. Because most of the functions on Android come out through the Java API, and there's no easy way to get directly to the native interface to make those calls. Obviously, these guys haven't gone in and ported all of the libraries from either Objective-C or from Java, from the Google APIs or the Android APIs. So they leverage what should be a fairly standard and well-known approach for traditional sort of Win32 developers, where you can leverage pinvoke to allow you to actually bring in an assembly reference, create a managed method, and allow you to marshal values in and out using int pointers and all those sorts of fun things. So that's a supported way of doing things for Objective-C. And on Java, the Xamarin team has actually built the concept of a thing called a Java binding library, which is part of their tooling setup, which will allow you to write your own wrapper effectively around the Java libraries that you want to use, or you can use the Java native interface or JNI if you want to do that sort of thing. So that's a way to avoid having to port this stuff. If you do find that you are going to be doing a lot of work in this space, and it doesn't make sense to keep marshalling items backwards and forwards, you can actually port the code if you so wish, but there's obviously a point at which you will still end up having to marshal something backwards and forwards between the native environment. So let's get to the fun stuff. And I saw the demo gods were a little bit angry this morning. The two demos I went to both had issues, so I'm not sure what could possibly go wrong with a PC and a Mac and an iPhone and an Android emulator and a Windows emulator, but let's see how we go. All right. Let's talk a little bit about the demo application before I get started. So the Xamarin guys have done a really good job of providing a set of samples to get you started with working on their environment. So my demo is based off of one of those samples, which is called TaskQ Pro, and it's a task manager. The one that they ship out of the box is designed for you as an individual user to use and just shows you how to write and deploy that application across the 3 platforms. I've extended that a bit to allow you to choose a user to whom you want to assign a task. When you assign that task, it writes it out to the Azure Mobile Services backend and then leverages the push notification capabilities of that platform to push it out to the right user on the right device. I have 3 users, Larry, Steve and Tim, and they each own a device of each of the flavours that we've talked about. I'm sure you can figure out who has which device. A little bit about the architecture at a high level. So our 3 handsets will have our application deployed to it and leverage the Azure client SDK that's appropriate for the platform that wraps all the APIs to generate JSON messages and call the REST API up in Windows Azure Mobile Services. That API will then pass that down into the Node.js wrapper, essentially, that sits in front of our database. And that will either execute a push into the database and then do a forward of a message using the push Node.js libraries that are available out through configuration effectively. So we'll look at doing the configuration as well to each of the native push notification services. So MPNS, which is the Microsoft push, and APNS, which is Apple's, and then GCM, which is Google's, which will then deliver the message actually back to the device. So you will have probably seen, if you've been looking at this stuff before, a lot of demos that will show you how to do one part of this, which will be to push it actually into Azure Mobile Services, but they don't necessarily go into too much detail about how to bring it back to you, or they'll bring it back to you and they'll show you how to do this in native code. So we'll have a look at how we do this all using C#, which would be fairly new because most of you would probably be working with Objective-C or Java to achieve this, but I think you'll be surprised there's actually not a huge amount of difference. This is what our database looks like, just a very high level, very simple. We've got a task table which contains obviously the task we're going to assign to somebody, and then a user device registration table. So this is a fairly simple scenario. We've got one device to one user, and we've got some Node.js scripts sitting around this that will allow us to do push notification and also manage duplication of entries in the device registration table. I've got a fairly simple approach, is I'm just deleting what's ever in there and then writing the device registration back into that table, just as a simple mechanism to manage the fact that things like Windows Phone can change the registration key on a regular basis, and it just makes it easier for the purpose of this demo to control that. You probably want to look at handling that in a different way because obviously that may mean something else to your application. It may mean the user's registered with more than one application. You do want to send pushes to both the devices they're registered on. But for the purposes of this, it's just a simple find the user, delete their record, and then create a new one for them. All right, so let's have a look at the iOS demo. This is what the environment looks like. Fairly complicated one. We've got Windows and Mac involved. I'm going to be using the Xamarin extensions for Visual Studio. So in order to have this, you need to have a Xamarin business level license. And they license iOS and Android development extensions separately, which I think is a good idea because you may not want to be target both those application platforms. And if you've paid for two, why would you want to pay for two when you only really need to focus on the one initially? On the Mac OS X, you have some Xamarin plumbing code installed, which is essentially a build host which you talk to over HTTP, and it leverages the Apple iOS SDK to actually build the application and deploy it up onto the device. I will say that if you've not worked with the iOS simulator, you're better off having a device if you really want to do development on this platform, because the simulator isn't very rich and it doesn't do simple things, even like receiving push notifications. You just get an error out of it. So luckily I have an ancient iPhone which I can use for the purpose of this demo. All right, so let's switch out into Visual Studio here. Let me just start up Zoom so I can zoom in for you. I sat up the back there yesterday and had a lot of trouble seeing what guys were showing, so let's see what I can do for you. So our solution looks a bit like that. Have you seen that? No, not seen that. Let's get it out onto the right screen would help. There we are. Oops. Okay. All right. Okay, that's not going to work. Bear with me one moment. This is going to be interesting. Right, so our application is literally all-in-one Visual Studio solution. This is Visual Studio 2012, just with the Xamarin extensions installed. So I have Tasky.Android app, which is our Android-based solution. I've got a core library which contains shared code that I can push across all three platforms. I have the iOS version of the application. Interestingly, it just has a C# logo there. I'm not sure why Android has a proper Android logo and the iOS one doesn't have a proper Apple logo. I suspect there might be a reason behind that. And then I've got it's a Windows Phone 7 application, but because I'm building it using the Windows Phone 8 SDK, it'll compile and run on a Windows 8 phone device anyhow. So let's just hop out of that and go to the iOS device and have a look at that. So these two mobile managers up here are the core of what we use to connect our code to the SDK that talks to Windows Azure. And these are both written as singleton classes so that we can leverage the mobile services client and manage our access to that so we don't have multiple copies of that flying around all over the place. These are all multi-threaded environments, so we do need to make sure whatever code we're writing is thread safe. We've got two managers that obviously map to the two tables that we talked about. We've got one to manage task update, save, and those things, and then one for user device registration as well. The way these are actually included down into our application is via linked file references. So if we have a look in our business layer here and in the managers folder, so at the moment I've only got task manager in, so let's go away and add a reference to this, add an existing item. So I want to go back up to my mobile services managers, user device manager, and I'm going to add this as a link. Okay, so now I've got that in there. The reason I have to add that as a link is that on the three platforms, the SDK that you use to leverage Azure Mobile Services has exactly the same namespace. So you can't build one class and one library and have three references to the three different assemblies that resolve to the same namespace. So to get around that, those two files live outside of a project, but when you add them in as a linked item, you can obviously reference them by namespace and then include the reference to the appropriate assembly in the project that you're actually wanting to build. So that's the C# code to actually manage the interface with Azure. The Xamarin tooling adds this new components item to projects. So you'll see I've already added the Azure Mobile Services component. So let me go and remove this. What I'll do is I'll just take us out of the screen zoom here. Okay. So if we choose to add a component to this, so it's maybe a bit small to see there, we'll do get more components. And we'd need to do this for both iOS and Android platforms as well, because they're shipped as different assemblies. So they're part of the one component set, but because we're targeting different platforms, we need to download it twice. So that loads this wonderfully large dialog, which is too large for this screen, and joyously the first item that comes up is the Azure Mobile Services SDK. So this is from Microsoft, so it's officially supported. Click on that. And then we can do add that. And then what we'll find is that we'll actually add a reference in the references folder. So we've now got a reference to Microsoft Windows Azure Mobile Services.ios, and we've got the component listed in here. The components quite often come down with samples as well, so you can go and browse the samples locally on your disk if you want to. So that's given us our hook into our mobile services component. And if we have a look in our manager class, let's open. Okay, let's open over here. So let's zoom out of that. So our task manager is leveraging the new async task approach. So we've got a call to system.threading.tasks. And what you've got to remember is that while these are system and system.collections.generic, these are actually going to be in the Mono environment. These are going to be the equivalents that have been implemented by the Mono team. So while we're working in Visual Studio here, we're compiling locally on Windows and we're leveraging Microsoft's implementation of C# and .NET. When we actually go away and deploy this, or if we were doing this development down on a Mac, for instance, we'd actually be leveraging the Mono version of those assemblies. So the compatibility is quite high between the two environments and allows you to do this sort of code. So as I said, this is just a singleton class which allows us to properly manage our connections out to the mobile service client, which is going to call our REST API and pass JSON objects about. We've got a table, which is our user task table. And then we've just got a default list, which is going to be our empty list of user task objects. We've got our instance to allow us to get our access to the singleton. And then we have a series of methods, and you'll see these are marked as async methods. And I'm simply putting in an await so that I can call that table, and I want to wait for this method to return. I want that call to return before I want this method to return, because I want the upstream callers to be dependent on it returning that item. By default, all of the calls out to mobile services use async approaches. So if you're not wanting to use async, you've got to do a little bit of dancing about to control that. So that's why we have an await in here. So we've got get tasks just generally, get tasks for user where we pass in your username, and you'll see it's just using a link and a lambda expression to actually go away and filter that, so we get only those tasks that aren't done and they're assigned to the current user. So this is all about task management. Get task by ID, so if we want to load a task to show it in an edit form, we can do that from here as well. And then we have insert, so the insert method calls a little bit different. I want to make sure that if the service call faults for whatever reason that I catch that, and then I can go back to the UI and I can say, sorry, the call didn't work, maybe you should try it again, rather than just blindly letting that service run in the background and assuming that it's going to have succeeded. So that's the task manager. The user device manager is very similar. I won't go through it in a great deal of detail because it should be very similar. You'll see it's got access to the table, to a mobile device client or mobile service client instance. This one's very simple. We call insert, And we don't actually wait for this one to return at all, so we just literally go insert the device registration. That's partly because of where I'm calling it in the iOS application. So iOS apps, if they don't start within 10 seconds, the application OS will actually kill the app. So you need to come up with a proper approach to allow you to start your application and then do all that sort of initialization stuff outside of the boot up of the application. For the purpose of this demo, I'm doing it in app start, but it's something to be aware of, which is why I'm kind of going, just insert this and I don't care whether it succeeds or not, because I just want the application to start. So I think this is actually pretty cool because it's all inside Visual Studio. So I'm actually building an iOS app inside of Visual Studio here. If you've done any iOS development before, you should see some similarities. So you still have your plist file. You've got an app delegate. So they've tried to keep the structure and the naming schemes fairly similar, so that hopefully transferal of skills from a native iOS developer down into someone working in this environment is not too hard. So it does mean that if you don't come from this background, there's probably some key concepts you need to pick up on, but I think if you're a fairly seasoned C# developer, you shouldn't have any issues with this. So I'll be clear and say I'm not a mobile developer by trade. I do a lot of web stuff and a lot of integration stuff, and if I can do this, I reckon pretty much anybody that's got C# experience can pick up and run with this sort of stuff. So that's sort of the adding the nuts and bolts into our application. So let's go and have a look at what changes we actually need to make to get this application to do push notifications down into the Azure environment and then back up onto other devices. So the first thing we're going to do is probably pop out to the Apple developer portal, because we're going to need to do some creation of certificates. So let's just get my Mac woken up here and change him over. Okay, cool. So that's a free tool called iTools, which allows you to mirror the screen. There are others out on the market that will allow you to do that. So let's go into here. So this is a developer portal. Obviously, to have access to this, you must already have registered for the developer program. For independent developers who don't want to do side loading of apps or management via MDM, that's $99 a year, and if you want to do enterprise, it's $299 a year. Let's get the password right. The joy of this was that, when I was preparing for this talk, Apple was actually offline for quite some time because somebody thought that it would be fun to try and get into the Apple portal via nefarious means. So they took me out for 3 weeks. So let's just go to Okay, so I'm assuming that at this point I've already created a provisioning profile for my application. So if we go and have a look at certificates, identifiers and profiles in the top right-hand corner, we should find a provisioning profile for the device that I've got up here that's already been set up. Okay. Now, the key thing with provisioning profiles from a push notification perspective is that you need to make sure that the application has actually been set up to allow push, which is on this page. Okay. All right, it's not going to show me that information, but effectively what you will have is there is a push notification. So let's go away and we'll create a new one. Let's create a new one while we're here. Just quickly show you. All right. So my apologies. There should be an element to the app ID that actually gives us the push notification, but effectively it's a configurable option that when you create the profile for the app, you say, I want this thing to be able to do push notifications. If you don't turn that on, it doesn't matter what else you do, you're not going to get the capability to actually do app pushes. So in order to do push notifications through Azure Mobile Services, we must have a certificate available to us to register in the Azure portal to allow Azure to talk to the APNS push service and do it in an authenticated mechanism. So what we need to do is we need to actually go away and use the provisioning portal to actually set up certificates. So let's walk through that process quickly. The challenge with this is that once you've created it, you need to export it and then export it with your private key to be able to import it into the Azure portal. You can't just take a standard certificate and upload it. You've actually got to have a PFX that includes the private key that you created when you created the certificate. The easiest way to do that, if you're working in this environment, because you're going to have a Mac to hand anyway, is to use a combination of Keychain, the Keychain app on your Mac, and the developer portal. So let's go ahead and create a new certificate to go into Azure. So we're going to click plus up here in our certificates. So we've got two types of certificates. We can have an Apple Push Notification Service SSL sandbox, which is for development purposes, and then we also have a production one as well. Azure Portal, as we see, supports both of those certificates. So if you have a life cycle you want to push your app through, you can support that using the right push notification SSL cert. So let's go ahead and we'll do a sandbox one. And we're going to continue out of that. So we're going to use the existing sample app that I've already created. So the CSR file is where we need to actually hop out to Keychain. So let's start Keychain to allow us to generate the certificate signing request. And then what we do is we're going to go up to Keychain and choose Certificate Assistant and request a certificate from a certificate authority. Okay, so it's going to pop up details there. Let's change that. Okay. We don't need to change anything else apart from save to disk. Save that. We'll save that down onto desktop. Give it a different name because there's already one there. Okay. So what we need to do is, now we've done that, we'll go back to the portal and it'll ask us to upload the file. So we'll choose that file on the desktop, which was down here. We'll open that, and then we'll click Generate. Right, so this is going to generate a certificate file for us. And what we actually need to do is we now need to import that with Keychain. So we'll see that when we've imported that, it's got my private key in there. So now what we need to do is we're going to export that. Where are we? Sorry. Okay, doesn't want to let me export that. So here's one I created earlier, thankfully. We'll export that. So it's going to ask us for a new name for that. So we'll call that certificates and we'll put it down on our desktop. We'll save that. It'll ask us for a password because it's including our private key. It's going to ask me the administrator details locally because it needs to use keychain to export it. So I'll enter my local Mac password and choose allow on that. So now I should find that down on my desktop, I've actually got the certificate P12 pack. So what I now need to do is I now need to go to the Azure portal. I'll do that on the Mac since how we're already here. Just check to make sure I get this right so we don't waste any time. So I've got my mobile service pre-configured here. I'm going to come into my push tab. So there's some information in my push tab already because I've obviously been running through this previously. What I'm going to do is I'm going to choose upload here for the certificate. I'm going to choose that P12 file that I created, which is on my desktop, just here. I'm going to open that. So I can choose whether I want to put dev or production. So this is my dev one. I'm going to type in the private key password and then click OK. This will overwrite the one that's already up there, so I've already uploaded one before. So that'll be uploaded and processed by Azure. So that's done. So that now means our Azure mobile service is connected to APNS, so we can route messages using the APNS push mechanism out of Azure. So let's switch back to our Windows box. Okay, good. And then what we're going to do down on our Windows box is just quickly make the necessary application changes to get us registered. So this first piece of code here, this is in our finish launching method, which if you're an Apple developer will seem familiar to you, so they've kept the method names as similar as they can. We're going to call some code to actually register this device natively. So we're actually calling a method out that says we want to register this app to allow it to receive alerts, badges and sounds, and that will go off and talk to APNS to make sure that the application is registered for it. If we look at registered for remote notifications, which is a method that we wire up to allow it to handle the return from that call to register for the actual push notifications. I've got some code in here which leverages my user device manager singleton to actually create a record up in our user database in Azure Mobile Services. And you can see I'm hard coding this in this demo to be user Tim, the fact that it's an APNS account, and then the service key is going to be whatever the device token is that's pulled back from the APNS registration that the device has done. Lastly, I'm just going to uncomment this. So that allows us to include those files that we added the link to. And then that's pretty much all we need to make at this point. So that will allow us to actually register the device with Azure Mobile Services. What I'll do also while I'm in here is we'll come into our screens folder. And in our screens folder, in our home screen, so we have a method down here. So I'll zoom in again so we can see that. So here we have a save task method which reads the context out of the dialogue that's displayed on the iPhone, converts it into our DTO, our business item, allows us to then call our task manager to run that back up to Azure Mobile Services. And then we finally have the ability to populate the tasks table from Azure Mobile Services. So at startup, what we'll do is we'll actually go off and call Azure Mobile Services to get the tasks back And then the last change we want to make here is to pull that in. So let's just build our solution. Make sure everything's happy. No. Okay, why aren't you happy? It's a Windows Phone 7 app, of course. So let's do this. We'll just exclude him from the project for the time being. And rebuild. All right, so that looks like it's happy. So all we do is we'll set our iOS application as our startup project. And then what we should be able to do is we should actually be able to debug this. So if we hit start, okay. So it's now trying to connect to the Mac host, which hopefully it will successfully do. Okay, good. So this is one of the trickier bits. If you leave the machines kind of sitting for a while, the Apple host has a tendency not to respond to requests anymore. So I had previously set this up to use a fixed IP address. We'll try once more. All right. So what we'll do is, since how that's not going to be happy, we've done the registration, so hopefully the setup, so the source code for this is all up on GitHub, so you guys will be able to have a look at it. We've had a look at the setup of APNS on the Azure Mobile Services portal. Let's go away and have a look at how we do this for Android. Android's a somewhat easier task. So in order to do this, we're going to use the Google console API. So we need to also have a Google account set up. So I've already registered myself. I don't have any apps in this environment. So I see this page. Let's just refresh that and make sure I'm still logged in. Yep. So I'm going to click Create Project. Okay, so I'm probably going to run to 12:45. You guys can grab me afterwards if you've got any questions. What I'll do is just do the Android app. Okay, so it looks like my session has timed out. Come on. Okay, so by default I have this standard API project that it's created for me. If I zoom in on that, I need to scroll down the page till I find the Google Cloud Messaging, which is just here. So I need to use Google Cloud Messaging for Android. Flick that switch to on. So I can now leverage Google Cloud Messaging for Android, which is cool. I do need to do a little bit of security work around that to allow API access to be secured. So I click up here on API access. By default, I get this browser app token. What I'm going to do is I'm going to create a new server key. I can't put an IP restriction around this because Azure Mobile Services can call this from anywhere. So we leave it without any restriction on IP. We'll create that. So that creates our new server key up here. So we care about our server key and we care about our project ID. So we'll need the server key in our Azure Management Console, so let's pull that up. That's just here. So we'll go into a mobile service here to push. And then Google Cloud Messaging. Okay, well, keep going. That's a fail on the zoomability of the Azure portal there. So the API key is the one that I've just generated. So I paste that in here and I'll save it. So we've now got access to the API mechanism via Azure, so it allows us to access the push notification services we just enabled. What we do need also from this location is down in our registration process for the device, when we actually register with GCM, we need to provide it with our project ID or our project key so that we can uniquely identify ourselves from everybody else. So you'll see here we've got what's called a sender ID. So what I actually need to do from the overview of the project, there's a project number. So that's actually my sender ID in this context. So I take that and then swap back over to here, paste that in here. So this method's using a fairly common way of registering the device, using an intent to actually say I need to register to allow me to receive Google Cloud Messaging messages. Google released Play Services, which is also a component that you can download from Xamarin. There's some incompatibilities with that in some of the older devices. This is by no means going to go back all the way into history with all the Google devices or Android devices ever created, but it's more compatible to do it this way than it is using Google Play Services at the moment. So let's uncomment this. So this actually calls that method below. So that's fine. So our task details screen, and I'll run this in a second so we can see the wonder of it. So we call Task Manager to load the task, and to insert the task. And let's just make sure on home screen that we're actually calling the service where we need to for that. Oh, okay. So in our business layout, we have notifications. So the way we register for notifications, we get an intent, which is basically an asynchronous task in the Android framework, which allows us to get the information back in a callback type mechanism. So we go to broadcast receiver, which receives the registration success method, and then we run a background task, which is an intent to actually record that in Azure Mobile Services. So let's just have a look at what that looks like. So this is our broadcast service. The neat thing with this is that traditionally a lot of Android developers would have had to have registered each of these items up in the manifest XML. With the Xamarin approach to things, you can actually register them using attributes on classes or methods in your individual applications, which is good. So this is our broadcast receiver, and when it receives a message, what it does is it's going to call our intent service. So let's swap over into our intent service. And then the intent service does a bit of dancing around with mutexes and waking up the screen in case the screen is locked, and making sure that we don't do that when another app's trying to do it at the same time. And then we do some simple parsing of the intent to see what it is. So if the intent is a registration, then we're going to use our user device manager to actually push this up into Azure. This same intent also receives the notifications being pushed from Azure Mobile Services and GCM as well. So this same block of code will run, but it's just that the action that the intent contains is going to be slightly different. So that should be all we need to run our Android app. So let's just run that up. Make sure that's going to build. Okay, good. So we'll start that. Now I've already got an Android emulator running because it's a bit of a beast to get running. mouse gone? Okay. So we'll just unlock him. So the tooling will actually give you output as well. As it's building, it'll tell you what it's doing. If you're doing an Android build, there's actually an Xamarin Android option to filter that so you can see what it's doing. And there's also a Mac server build log as well so you can see what's going on behind the scenes as well. There are some challenges sometimes, as you've seen, with Mac services not responding to requests. Usually a restart of the Mac fixes that. It's not ideal, but it's important to note that new technology, 6 months old, pushing the boundaries here. We're doing cross-device development using one platform. Cool thing there, probably very subtle and something you're used to seeing every day, is that's actually a breakpoint inside of IL that's been deployed to an Android device. So I'm actually debugging C# code that's deployed on an Android device inside of Visual Studio. So if I go back to my code over here, that application is currently frozen because I've got a breakpoint set on that code. So if I just F5 that, okay. All right, Microsoft Visual Studio is busy. Thank you for that. So it's frozen. Okay. All right, the demo gods certainly haven't smiled on me today, that's for sure. Come on. Come on. All right, so rather than me continue to bang on about that, that looks like that's gonna, oh, no, an unhandled exception occurred. Okay, continue. No, okay. Yeah, all right, so my app crashed. Why that was, I can't tell you. I'd have to go and have a look at the debug log. It does happen from time to time. Okay, so I'm very much aware of the time, so what I'll do is I'll wrap up. As I said, the source code for this demo is up online. I'm here across the next couple of days. More than happy to sit down with you and go through demos end to end, show you how it all works, and talk you through the process that's involved. So let's just quickly wrap up with a few final slides, and then let everyone get off to lunch so that there's actually some food left for you out there. So I think just a few other key takeaways, despite the fact my demos didn't go well today, never mind. Azure Service Bus notification hubs are relatively new, so Android was the last one to be added, so it allows you to do broadcast or multicast off of a service bus using push notification services. So the application that we've looked at is very much a point-to-point. I create something, it pushes to somebody else. Azure Service Bus notification hubs allows you to do broadcasts of similar sorts of things, so that's cool and new. You can also target Windows 8 and Mac desktop. The Xamarin guys have a Mac extension to allow you to write Mac apps, which will tie into obviously the APNS capabilities of that platform, and Windows 8 apps. So the Microsoft Push Notification Service can drive Windows 8 or Windows 8.1 apps. Source code's up on GitHub for this. It's already there if you want to start pulling it down. It does work, trust me. So I'm from Sydney. If you are in Sydney and you're interested in Azure, I run the Azure user group in Sydney. Please come along. Our next session's on September 19, where we talk about the controversial topic of Linux on Azure, how to run it and how to also manage Azure from Linux. Great place to get up-to-date news. Scott Gu, who's obviously going to be here, follow him. Windows Azure as well. I work for Cloud. We've got a great bunch of guys who do a lot of good blogging about Azure tips and tricks, IDM, Office 365, all that fun stuff. My blog's there, blog.siliconvalve.com. We'll skip the questions. Please come and see me afterwards if you want to talk to me or grab me over the next couple of days. Thank you very much for your time. Appreciate it. Sorry the demos didn't go so well, but hopefully you've picked up a lot along the way. Thanks, guys.